Hello everyone. In this video, we are going to discuss about formal charge from the chapter 4 Chemical Bonding and Molecular Structure, class 11 Chemistry. See, formal charge of an atom in a molecule, it is a theoretical concept that helps to predict the stability and reactivity of the molecule. In general, the Lewis dot structures, see we have already discussed about Lewis dot structures in our previous video which is available in the playlist. See, the Lewis dot structures do not represent the actual shapes of the molecules. In a polyatomic ion, the net charge is possessed by the ion as a whole or not by a particular atom. See, the formal charge of an atom in a polyatomic molecule or ion that may be defined as the difference between the number of valence electrons of that in an isolated state of free state and the number of electrons assigned to that atom in the Lewis structure. You don't have to worry about these sentences. The easy formula to get the formal charge of an atom in a Lewis structure is the formal charge is equal to, I am just representing the formal charge with these two letters Fc. So, formal charge is equal to total number of valence electrons. Okay, this is total number of valence electrons in the free atom minus total number of non-bonding non-bonding electrons minus half of total number of bonding electrons. So, the formal charge of an atom can be calculated in a Lewis structure can be calculated by using this equation. That is, formal charge is equal to total number of valence electrons in the free atom minus total number of non-bonding electrons, that is lone pairs, that is the electrons which have not participated in the bonding, then minus half of total number of bonding electrons or shared electrons. See, the counting of electrons, that is based on the assumption that the atom in the molecule owns one electron of each shared pair and both electrons of the lone pair. So, let us first consider a simple example of carbon dioxide molecule. After that, we will consider the ozone molecule. When we consider the carbon dioxide molecule, you see the Lewis dot structure for carbon dioxide molecule is like this. C double bond O double bond O. Okay, here you see in carbon dioxide we have one carbon atom, two oxygen atoms. See, carbon atom, its atomic number is 6. So, electronic configuration 2, 4. So, number of valence electrons in the free carbon atom is 4. When you consider oxygen, its atomic number is 8. So, its electronic configuration will be 2, 6. So, number of valence electrons in the free oxygen atom is 6. Okay, so this is the Lewis dot structure for carbon dioxide. Now, let us number these atoms as 1, 2 and 3. Now, consider the oxygen atom which is numbered as 1 first. Then formal charge on this oxygen atom 1 will be equal to total number of valence electrons in the free atom minus that formula. So, total number of valence electrons in the free oxygen atom is 6. So, 6 minus total number of non-bonding electrons. So, total number of non-bonding electrons, that is lone pairs 1, 2, 3, 4. So, 4 minus half of, that is half into total number of bonding electrons or shared electrons. So, when you consider this oxygen atom, there is one double bond here connected with this oxygen atom. So, double bond means a single bond, it has 2 electrons. So, double bond 4 electrons. So, half into 4. Total number of bonding electrons or shared electrons is 4. So, half of that value means half into 4. So, this will be equal to 6 minus 4. 2 2s are 4. So, minus 2. Okay. 6 minus 4 minus 4 minus 2 is minus 6. That is 6 minus 6 which is equal to 0. That is formal charge on this oxygen atom 1 is equal to 0. Now, let us find out the formal charge on this carbon atom which is numbered as 2. So, the formal charge on this carbon atom will be equal to number of valence electrons in the free carbon atom which is 4 minus number of electrons, that is number of non-bonding electrons. So, non-bonding electrons, no non-bonding electrons are given here. So 0 minus half of number of bonding electrons. So you see, connected to this carbon, there is double bonds here, double bond here. That means 4 bonds are here. One single bond corresponds to 2 electrons, shared electrons. So 4 bonds here from carbon. So 4 into 2, 8. So half into 8. Shared electrons, 8. So this will be equal to 2 4s are 8. So 4 minus 0 minus 4. This is like 4 minus 0, 4. 4 minus 4 is 0. So formal charge on this second carbon atom, that is carbon atom numbered as 2, is equal to 0. Okay. Similarly, let us consider this oxygen atom which is numbered as 3. The formal charge on this oxygen atom will be equal to the total number of valence electrons in the free oxygen atom, which is 6, minus the total number of non-bonding electrons, that is 1, 2, 3, 4, 4, minus, okay, half of total number of bonding electrons or shared electrons. Connected to this oxygen, there is a double bond here. A single bond corresponds to 2 shared electrons. So double bond, 4 electrons. So half of 4. 2 2s are 4. So this is like 6 minus 4 minus 2. Okay, which will be equal to 6 minus 4 minus 2 is 6. So 6 minus 6 is 0. Okay, now what about you see the formal charge on carbon atom is 0. Formal charge on each oxygen atom is 0. So the total formal charge on this carbon dioxide is equal to 0. That actually indicates that carbon dioxide is a stable molecule. Now, let us consider another case which is of ozone molecule. Ozone molecule has actually 3 oxygen atoms, O3. Okay, so you see the Lewis dot structure for ozone molecule that can be drawn like this. Alright, the bonding and lone pairs are already shown here. So this is the Lewis dot structure for ozone molecule O3. And the atoms have been numbered as 3 oxygen atoms are there. The atoms have been numbered as 1, 2 and 3. Okay, now the formal charge on the central oxygen atom numbered as 1. That will be equal to what? The oxygen, its atomic number is 8. So electronic configuration will be 2, 6. Number of valence electrons in the free oxygen atom is 6. So formal charge on the central oxygen atom numbered as 1 will be equal to number of valence electrons in the free oxygen atom, which is 6, minus number of non-bonding electrons. Non-bonding electrons, that is 2. Okay, minus number of bonding electrons or shared electrons. So connected to this oxygen atom, a double bond here and a single bond here. So 3 bonds are there. Corresponding to 1 bond, 2 shared electrons. So 3 bonds, 3 into 2, 6 shared electrons. So half of 6. Okay, so this will be equal to 2 3s are 6. So 6 minus 2 minus 3. So this is like 6 minus 2 minus 3 is minus 5. 6 minus 5 is 1. 1 means plus 1. Okay, similarly, the formal charge on this oxygen atom which is numbered as 2. So the formal charge on this oxygen atom numbered as 2 will be equal to total number of valence electrons in the free oxygen atom, which is 6, minus total number of non-bonding electrons 4, minus half of total number of bonding electrons. See, connected to this oxygen atom there is a double bond here. So a single bond corresponds to 2 electrons. So double bond 2 into 2 4. So half of 4. See, 2 2s are 4. So this is like 6 minus 4 minus 2, which is equal to 6. Minus 4 minus 2 is minus 6. 6 minus 6 is 0. Okay. Now consider this and oxygen atom which is numbered as 3. So the formal charge on this oxygen atom 3 will be equal to total number of valence electrons in the free oxygen atom, which is 6. Okay. Minus total number of non-bonding electrons 2, 4, 6. 6 minus 6. Minus half of total number of shared electrons. See, connected to this oxygen atom there is a single bond here. A single bond corresponds to 2 electrons. Okay, so total number of shared electrons is 2. So half of 2. So 2 2 cancelled. So this is like 6 minus 6. This is like minus 1 here. Okay, 6 minus 6, 0, 0 minus 1 is minus 1. So the formal charge on this end oxygen atom numbered as 3 is minus 1. Okay, now what about the net formal charge on this ozone molecule? See, the net formal charge will be the sum of these individual formal charges. That is, net formal charge or total formal charge will be equal to plus 1 plus 0 plus minus 1. So this is like plus 1 means 1 plus 0 plus minus 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 1. 1 plus 0 1, 1 minus 1 is 0. So the net formal charge on this ozone molecule, that is equal to 0. Okay, this net formal charge is equal to 0. This actually indicates that this structure of the ozone molecule, it is a stable structure. Okay. So you see, the formal charge on the first oxygen atom, that is the central oxygen atom, is plus 1. And the formal charge on this oxygen atom, this end oxygen atom numbered as 2 is 0. And the formal charge on this end oxygen atom, which is numbered as 3, that is minus 1. So we represent the ozone molecule O3 along with the formal charges as the central atom has a positive formal charge. This end atom has 0, no? So nothing. So this end atom has a minus formal charge. So this is how we represent the ozone molecule along with the formal charges. The formal charges do not indicate the real charge separation within the molecule. For example, if you consider the carbon dioxide molecule, this is the Lewis structure for the carbon dioxide molecule, and the formal charge on this carbon is 0, formal charge on each oxygen atom is 0. So these formal charges suggest no charge separation. But actually, central carbon atom, it is partially positive. Okay, central carbon atom is partially positive and oxygen atoms are partially negative. So actual charge separation depends on electronegativity, molecular geometry and other factors. See, the charge on the atoms in the Lewis dot structure only helps in keeping track of the valence electrons in the molecule. The formal charges help in the selection of the lowest energy structure from a number of possible Lewis structures for a given species. The lowest energy structure typically has the smallest formal charges on atoms. The formal charge is a factor based on a pure covalent view of bonding in which electron pairs are shared equally by neighboring atoms. So in this video, we have discussed about the formal charge, and formal charge is equal to the total number of valence electrons in the free atom minus total number of non-bonding electrons, lone pairs, minus half of total number of bonding electrons or shared electrons. I hope the idea of formal charge clear to you. Thank you.